In this video, I will be teaching you the basics on torque and angular acceleration in physics. For today's first lesson, here are some very key details that we will be using. Torque is equal to radius times the force. Torque is the measure of a force like a push or pull on an object with a specific axis. Here is an example question 1. Follow with me as I show you how to do a step-by-step process. Here we have a bar that has a center axis point with 3 separate forces acting upon it. 2 are counterclockwise and 1 is clockwise. We will dive into that a little bit later. As you can also see, 2 of them are acting upon this bar at an angle of 60 and 50 degrees. So if we set up the equation that torque is equal to radius times force, then we have what is here in the image. F1 times R1 equals torque 1, F2 times R2 equals torque 2, and etc. These will all equal a different force on the bar and may push against each other, making a negative force known as a clockwise force. So on our bar, we only have one clockwise force, so there's one negative force in the equation. You would normally just multiply the forces and the radius together from the center axis, but in 2 cases here we have to add an angular force with a trig function sign. This is also quite easy because all you have to do is add one more step of multiplying by sine and set angle that you get for torque. So what we have here is negative 300 times 4, which is the radius the force is applied on the bar. Then the force that's applied on the bar of 600 at the angle of 60 is multiplied by 3 because that's the radius, and sine of 60 because it's coming on at an angle, and so on. Once you have done all the calculations for torque, now you can come add and subtract the torques to gain the torque total acting on the bar. So you'd have the negative 1200 because that is a clockwise force, and then the 2 counterclockwise forces are adding to the equation. So the total torque net on the equation would be about 2,274 Newton meters. Now for the second topic of this video, Newton's second law for rotation, known as angular acceleration and inertia. The equation you want to keep in mind is torque is equal to the inertia times angular acceleration, and you also want to notice that inertia is mass times radius squared. Here's some important information that you'll need to know for Newton's second law of rotation. How torque and gets to that equation of angular acceleration is torque divided by inertia, and inertia being I. Here is example question 2. Here we have a box hanging from a wheel. The box is 0.3 kilograms and its radius from the center is about 0.2 meters. And the box is 1.5 meters from the ground. The wheel has a radius of 0.25 meters. If the box takes 1.1 seconds to hit the floor, what is the angular acceleration and the inertia of the wheel? We know that the inertia, the initial velocity at the start is 0, and the floor is 1.5 meters from the box. It takes 1.1 seconds to get there too. We can use the equation delta x is equal to VOT plus 1/2 AT squared. Once you have that equation, we plug in the numbers that we know. So we now have 1.5 equal to 1/2 A times 1.21. Once you do that, you'll have the acceleration at 2.48. Now here are the the force and torque equations. We divide 2.48 by the radius of where the box is hanging on the wheel, so 0.2, because we need the angular acceleration, which is acceleration divided by r equals angular acceleration, which gets us 12.4. Here are the answers related to my physics final part 2 and do not have anything to do with the torque and angular acceleration video. Thank you for coming to watch this video, and hopefully it helped you learn some things about torque and angular acceleration.